Welcome to How to Test a Circuit with the Load Connected. In this lesson, you'll see why circuit tests must be done under load, how to execute an effective voltage drop test, and the critical mistakes to avoid when diagnosing electrical faults. A basic continuity or resistance check may suggest a circuit is fine, but real circuit function depends on whether current can flow with the load connected. An open circuit prevents current, so the load does nothing. A short drops all the voltage elsewhere, also preventing proper operation. Only a test with the load actually reveals if the circuit can carry current when needed. To test a circuit with the load connected, use the multimeter to measure voltage drop across each part of the circuit while the component is operating. Place one meter lead at the power side, the other at the load terminal, and read the voltage while current is flowing. If the path is good, the drop should be low, typically under 0.2 volts in most sensor or control circuits. High voltage drop proves excessive resistance hidden from a simple continuity check. A voltage drop near zero means the circuit is carrying current with little resistance. This confirms the path is good. But if you see a high voltage drop, current is forced through excess resistance. This means corrosion, a damaged wire, or poor connector is still present, even if continuity checks look fine. Use these results to isolate the fault to either the power or ground side, and avoid replacing parts unnecessarily. Effective circuit testing follows a path. Identify the symptom, confirm the circuit is powered and loaded, measure voltage drop, and use the readings to pinpoint the root cause. This approach prevents guesswork, wasted parts, and missed faults. A common mistake is trusting a continuity test or circuit resistance measurement without the circuit operating. These methods miss high-resistance faults that only appear under load. Never replace parts based solely on a continuity check or a single clue. Always confirm the fault with a loaded test. Remember, always test circuits under load for real diagnostic proof, and let your evidence, not assumptions, lead you to the solution.